Welcome to today's Explainer. Look, if you're gearing up for those math exams and feeling just a bit swamped by all the formulas and figures, you're in the right spot. We're going to completely transform your Form 1 Chapter 10 revision into a logical, totally stress-free toolkit. We'll break down perimeter and area so clearly that you'll literally never second-guess a formula again. Let's get into it.
Okay, let's dive into this roadmap. Here's our scaffolded revision journey for today. First, the basics of perimeter. 2, conquering area and formulas. 3, solving shaded region puzzles. 4, the perimeter versus area showdown. And finally, number 5, final revision and tips. Getting this mental workspace organized is absolutely the first step to mastering the math.
Section 1. The basics of perimeter. The outside boundary. Let's start with that first foundational building block, focusing right on the very outer edges of 2D shapes.
So what is it? Perimeter is simply the distance around the outside of a two-dimensional figure. It's like walking along a fence that encloses a yard. We're only calculating that boundary. We don't care about the grass inside the yard just yet, right? We are strictly measuring the fence.
Now, calculating perimeter is at its core, literally just adding those outer lines together. Take a look at this cheat sheet. For a triangle, you're just adding sides A, B, and C. For a square, well, since all 4 sides are identical, it's just 4 times side A. A rectangle, just 2 times the sum of A and B. And for a circle, the perimeter gets a fancy name, the circumference, which is 2 times pi times the radius. Basically, just trace the outside.
But here's a question you might actually run into on an exam. What if the shape isn't perfectly straight? Like, what if it has an irregular curve? How in the world do we measure its perimeter when those standard straight line formulas just don't work?
Well, the solution is wonderfully practical. Step 1, you just take a piece of thread and carefully lay it along the exact curve of the object. Step 2, you pull that thread straight and measure its length against a standard ruler. And finally, step 3, you add this newly measured thread length to any straight sides the object might have. It's a simple, tactile hack that makes the math feel totally tangible.
Section 2. Conquering area and formulas. Measuring the surface. Now that we've mastered the outer boundary, we're shifting smoothly to the inside surface. Time to level up our tools.
We really need to distinguish this from perimeter. Area is the quantity that expresses the amount of surface a two-dimensional shape covers, and it's always expressed in square units. So we're no longer measuring the fence. We're finally measuring how much grass is actually inside the yard.
Before we jump into abstract formulas, let's ground our understanding of what area physically is by looking at how we can estimate it for irregular shapes. First up, the grid method. You place a grid right over the shape, count up all the full 1-unit squares, and then count the squares that are half full or more, and just add them all together. Alternatively, there's the parallel lines method. You draw lines exactly 1 unit apart from each other, assuming each line creates a rectangle with a width of 1 unit, and you sum up their areas. Both of these are fantastic ways to actually visualize surface space.
Now, what's really interesting about this slide is it's basically your essential revision table for area formulas covering the triangle, the parallelogram, the kite, and the trapezium. But hey, massive warning for your exams here. For the triangle and the parallelogram, the base and the height must always be at right angles to each other. Don't let a slanted side trick you into using it as your height.
And you know, if you ever freeze up and forget the formula for a parallelogram, just remember this really logical transformation. A parallelogram is basically just a slanted rectangle. Think about it. If you visually cut off the slanted triangle portion from one side and slide it over to the other side, boom, it forms a perfect rectangle. That's exactly why the formula is just base times height. No arbitrary rules to memorize here.
Section 3. Solving shaded region puzzles, the boss battle. Let's move to and see how this builds into what I like to call the exam boss battles. Shaded region questions. But really, they're just logical deduction puzzles.
So imagine this classic real-world problem straight from the curriculum. You've got a rectangular plot of land. Inside it, there's a triangular region used for planting banana trees and a trapezium-shaped region used for rambutan trees. The remaining shaded region? That's for planting papaya trees. So how do we find the area specifically for the papayas?
And this brilliantly illustrates a foolproof, 3-step, actionable framework you can use to solve absolutely any shaded region problem, totally stress-free. Step 1. Calculate the total area of the entire shape, in this case, the big rectangular land. Step 2. Calculate the areas of the unshaded regions inside it. Step 3. Simply subtract the unshaded areas from the total area. Whatever is left over, That's your shaded region.
Okay, let's walk through it using our source problem's dimensions. First, the total rectangular land area. The length is 12 plus 4, which gives us 16 meters. The width is 5 plus 5, giving us 10 meters. So length times width, 16 times 10, gives us a total starting area of 160 square meters.
Next up, we isolate those unshaded fruit plots using the formulas we just revised. The banana plot is a triangle, right? So half times a base of 4 times a height of 5 gives us 10 square meters. Now the rambutan plot is a trapezium. That's half times the sum of the parallel sides, which is 3 plus 4, multiplied by the height of 5. That calculates out to 17.5 square meters. And finally, this satisfying conclusion. We take our total area of 160 square meters, subtract the 10 for the bananas, and subtract the 17.5 for the rambutans. This leaves us with exactly 132.5 square meters for this shaded papaya region. See? By breaking it down step by step, that scary exam puzzle becomes a total piece of cake.
Section 4. Perimeter versus area showdown. The deeper connection. Now we're building up to the final major concept of this explainer, putting perimeter and area head-to-head.
So the crucial point is how these two metrics actually react to being stretched. If you have a fixed perimeter, like say a set length of fence, the area inside actually decreases as the difference between your length and width increases. Conversely, if you have a fixed area, meaning a specific amount of surface space you need to cover, the perimeter boundary you need will increase as the difference between the length and width increases. They move in completely opposite ways depending on the shape's proportions.
And that brings us to the ultimate rule. For a fixed perimeter, the area will be the largest when the rectangle is a square. And for a fixed area, the perimeter will be the smallest when the rectangle is a square. A square is perfectly balanced. Honestly, this is an intuitive cheat code that will save you so much time analyzing shapes during your exams. Section 5. Final revision and tips. You made it to the final segment. Let's rapidly recap this entire journey so you are completely empowered to tackle these topics.
All right, here's your ultimate explainer cheat sheet. Perimeter, strictly the outside distance boundary. Area, the inside surface quantity in square units. For those shaded region boss battles, always remember, total area minus the unshaded area. And finally, the square rule. Squares give you the maximum area for a perimeter and the minimum perimeter for a set area. Before we wrap up, I'll leave you with this provocative thought to ponder. If you were buying expensive materials to build the outer walls of a real-world house, how could applying this square rule to your floor plan save you literally thousands of dollars while giving you the exact same amount of living space inside? Think about it. Good luck with your revision and keep learning.